Hello everyone, this is Ankulari and I'm going to present the InstantID framework. So, InstantID is a model developed for zero-shot identity preserving generation, which can generate high fidelity images with a single reference image in any style. It uses a novel identity net framework that combines facial and landmark images with a textual prompts to guide image generation, ensuring identity preservation and high fidelity. The implementation lacks three types of problems, as I found. One of the toxicity problem, another one is the phishing issue, and the long prompt and summarization. So the toxicity problem is that attacker may add toxic words to the prompt. This may produce a different result to the what user expects. We have 6 types of text: toxicity, severe toxicity, off-scan, threat, insult, and identity attack. In our improvement, we checked if there is a toxic word in the prompt using a pretend LLM model. Phishing issue is that attacker may want to generate image with a false information. For example, generate an image with a crowd people wearing t-shirts with the logo of Pepsi protesting outside government building against environmental law. We use a pretend LLM model to check if this contains a false information or not. Another one is a long prompt and summarization. The long prompt summarization is that there is no restriction given in the pipeline about the length of the prompt. So long prompt takes a longer time to generate image. That's true. If we provide a document in the long prompt, then it should take a lot of time. But we think that if we summarize, then it actually it theoretically it will definitely improve the runtime. So we did two summarization process and one NLP keyword extraction technique we used here. So let's dive into the code. So first of all, we have info pool, and that is the prompt using. So that is the variable we are using is improved on or not. So first we have a very simple, we are using very simple, and is improved on means that we are not right now working on our implementation. That is completely the InstantID implementation. I think I should change the original. So right now we'll generate we are generating the InstantID implementation. Is creating a main.js. Okay. So right now, then we are going to implement is improved on. So we are checking our improvement. First of all, we are using is improved on. That in that case, we actually take it out and is from is toxic or not, and then we comment it out. So if you see that the prompt is not actually toxic, toxicity percentage are printed out here. Severe toxic, off-scan, threat, and insult. This implementation is in the util.py, where we have the detoxify module, a library to predict the prompt is check any text is toxic or not. We have 6 types of toxicity, severe toxicity, off-scan, threat, insult, and identity attack. And then result star item, that is toxic the threshold. So that is the implementation, and then the result is generated. Now we are using the toxic prompt. So what is the toxic prompt? That is actually saved in the prompt.py. So in the toxic prompt, we actually want to check if that is toxic. Yeah, that is toxicity is 21%. Others are different. It is not classified. It is classified as toxicity. So in that case, your prompt is toxic, unable to generate photos. Now we are going to introduce the phishing one. So in case of phishing one, the prompt, now we are going to take it as a prompt. So now saving the file to check. I hope that that will pass. Yeah, that is pass. It is normal prompt, so there is nothing to be as prompt. We have again now long prompt. In this long prompt, we are actually going to check if that long prompt has the, oh, it is passed. So it actually varies different time. I run multiple of time, but sometimes it the same prompt gives me different result. If you use the phishing prompt, then still, but if we run again, then we may find out that it is actually phishing or non-phishing. So in that case, we use the BART tokenizer pretend and then the BART sequence classifier. So based on that BART sequence classifier, the prediction is score is softmax and the predict. I think that there should be something improvement scope here to check it out, because if I run again, it may or may not. It is not actually accurate. For example, this time I'm running the same prompt, but it is actually the 54%. So it is printing out that your prompt is phishing and contains harmful info. So I think that there is this a scope to improve here. And another one, the last thing actually is summarization techniques. In case of the summarization technique, actually there's three types of summarization. So I'm just commenting out them. And then first of all, the T5 generator, T5 summary generation. So changing out the file name, long, long prompt T5 summary result.jpg. In that case, it is kept as true. So the prompt will be summarized. Seeing that is something, it's not phishing prompt, it should be long prompt execute. So now it is long prompt and around 10K words added in the prompt.py. It's long prompt. So sorry, py. So T5 summarization is basically model T5 for considering, and the tokenizer we used. Similar for the BART we used, and it takes around 34 seconds to generate the result. And the BART summary is similar. So BART summary generation, changing the file name, BART summary. It is taking around 27 seconds. And now I'm going to keyword. I'm in the last, I will actually compare the results. Just run it again. Keyword summary. And then just run it again. So in that case, keyword is NLTK used and the words and the word tokenize. Based on that frequency dictionary, we use the keywords word for, and then we join the keywords like something array or a string, comma separated string. It is also taking 27 seconds, but unfortunately the T5 generation, it takes around 34. Now I'm going to shut it down. That is improvement false. So that means that we are originally printing it, the long prompt. I guess it should take around 28 seconds. And it's around 27 seconds for similar one. I'm actually taking consideration that overall pipeline. So if we consider only the prompt generation, sorry, I mean that image generation part, then it should be like that. So that is from my side today. Thank you. So this is the second part of my video. Actually forgot to show the result of the video. So the long prompt, if we check it out, the long prompt result is something like that. And based on that long prompt, if we use the summary, T5 summary, then the quite similar, that the background is actually something like globe one. But we have something books are there, so that's different because it is summary, so it is pre-trained model. So new points are being added in the in the model, and then long prompt. If we use BART, in that case, BART is completely globe. We don't see any book here, and in the last one, we have something called keyword extractor. I think that in the prompt, there's something called book. So in the keyword extractor, it actually takes a lot of time, books in there, but there is no globe in that. So that is actually completely different based on the different techniques, different models. So there is no way to tell which one is the best. But yeah, I think that based on the runtime, we can infer that, yeah, we can, for a long document or long type of prompt, we can use that. So I forget in the first part to show the result to you guys, and this is the one. This is actually pushed on in my GitHub link, so you can easily see my result there, and you can run that. Thank you. Have a good day.